LSTM forecasted a straight line. I built an LSTM in keras. It reads observations of 9 time lags, and predicts the next label. For some reason, the model I trained is predicting something that is nearly a straight line. What issue might there be in the model architecture that is creating such a bad regression result? Input data, hourly financial time series, with a clear upward trend 1200 plus records. Input data dimensions. Originally reshaped for LSTM. Target data, y_train. LSTM design. Input layer of 9 nodes. 3 hidden layers of 20 units each. 1 output layers of 1 unit. The keras default is return_sequences equals false. Model is compiled with msloss and ATOM or SGD optimizer. Model is fit in this manner. Batch is 32, shuffle can be true/false. Config and weights are saved to disk. Since I'm training several models, I load them afterward to test certain performance metrics. I've trained several of the LSTMs, but the result against the validation set looks like this. The second plot, LSTM plot, is of the validation data. This is y_validation versus predictions on z_validation. They are the last 135 records in respective arrays. These were split out of full data, i.e. validation, and have the same type/properties as z_train and y_train. The x-axis is just numbering 0 to 134 of the index, and y-axis at the value of y_validation or the prediction. Units are normalized in both arrays. So all the units are the same. The straight line is the prediction. What idea could you suggest on why this is happening? I've changed batch sizes. Similar result. I've tried changing the return_sequences, but it leads to various errors around shape for subsequent layers, etc. Information about LSTM progression of msloss. There are 4 models trained, all with the same issue of course. We'll just focus on the 3 hidden layer, 20 unit per layer, LSTM, as defined above. Mini batch size was 32, and shuffling was disabled. But enabling changed nothing. This is a slightly zoomed in image of the loss progression for the first model, ATOM optimizer. From what I can tell by messing with the index, that bounce in the loss values, which creates the thick area, starts after in the 500s of epochs.
Your code has a single critical problem, dimensionality shuffling. LSTM expects inputs to be shaped as batch_size, time steps, channels, or num_samples, time steps, features, whereas you're feeding one time step with 9 channels. Backpropagation through time never even takes place. Fix, reshape inputs as 1212, 9, 1. Suggestion: read this answer. It's long, but could save you hours of debugging. This information isn't available elsewhere in such a compact form, and I wish I've had it when starting out with LSTMS. Answer to a related question may also prove useful, but previous links more important.
Overlord Gold Dragon is right, the problem is with the dimensionality of the input. As you can see in the keras documentation, all recurrent layers expect the input to be a 3D tensor with shape, batch_size, time steps, input_dim. In your case, the input has 9 time lags that need to be fed to the LSTM in sequence, so they are time steps. The time series contains only one financial instrument, so the input_dim is 1. Hence, the correct way to reshape it is 1212, 9, 1. Also, make sure to respect the order in which data is fed to the LSTM. For forecasting problems, it is better to feed the lags from the most ancient to the most recent, since we are going to predict the next value after the most recent. Since the LSTM reads the input from left to right, the 9 values should be ordered as x_t9, x_t8, ... x_t1 from left to right, i.e. the input and output tensors should look like this. If they are not oriented as such, you can always set the LSTM flag go_backwards equals true to have the LSTM read from right to left. Also, make sure to pass numpy arrays and not pandas series as x and y, as keras sometimes gets confused by pandas. For a full example of doing time series forecasting with keras, take a look at this notebook.